Okay, so look, so factoring means rewriting an expression. So one of these can be rewritten in a new way, and one of them cannot. So obviously the only difference is the minus sign or the plus sign. So remember, technically they could both be written with a 0 in the middle, right? They're missing that middle term. So technically, sometimes it's helpful to look at it with a 0 in the middle. You don't have to think about it this way. 36 is a perfect square, so you can just factor it by square rooting, or you can go about it this chart method, what multiplies to negative 36 and adds to 0. Right? And then this one, what multiplies to positive 36 but adds to 0. And some of y'all heard me talking about this yesterday. Some of y'all probably didn't, so I wanted to highlight it again. So things that would multiply to negative 36 and add to 0, 6 times negative 6. So this one can be factored into positive 6 and negative 6. That's the factored form. And you can just memorize when you have a perfect square and a perfect square, the factors are the first and the second square rooted. And you have to use a plus sign and a minus sign. The opposite six cancel out, causing the middle to be 0. Has anybody figured out what multiplies to 36 and adds to 0? Positive. 0. It's nada, nothing. You can't do it. So this one cannot be factored. Okay. Fairly likely to show up on an SAT, the difference between a difference of two squares versus sum of two squares. So you want to remember the difference can factor, whereas the sum, the plus sign, cannot. This is not the case with perfect cubes. The whole worksheet that you guys did where you did the pattern is 2 cubes, you can factor a sum of 2 cubes or a difference of 2 cubes, but that's only true with squares up. This one cannot be factored. So get out your homework. I think we did 2 out of 4 problems together yesterday. No. Was it? Yeah. Here's 23 and 24. Yes. Wait, can you open it to yeah. I knew she had a schedule. Sorry, I'm so sorry. Excuse me.
The actual class sucks though. FOBS class. Like deviated. I mean, I just looked at the answers.
First step, because this has a b, I took a greatest common factor of b out, and then I just have b squared b in regular 16. So this stayed here, and I set it equal to 0. And then this factored -4 and -4. Okay, does anybody have a question about these 4 problems? 23?
Okay, yeah, I got it.
Take those t minus 8.
You had a question?
How do we keep you so nice?
Then you take t plus 5.
Let me do it once.
And then the t squared equals 0. So
Yeah.
you have 2.
I need that. I might take it back.
Yes. Okay. Any other questions? All right, I have 6 problems here to do with you. I am going to give you a mini quiz on these problems tomorrow. I'm trying to differentiate from what I heard yesterday. Some people are really remembering factoring, doing fine. Some people are like, no, I need help with this. So if you want to use this on the quiz tomorrow, you can. However, it's like a 15% penalty. So it's an 85. It's an 85, you guys. It's an 85. So you can use this handout on your quiz tomorrow, but the highest score you can earn is an 85%. It's going to have different numbers, but it's going to follow the same patterns. Okay, so shh. You don't have to decide right now if you want to use this. You don't have to decide until tomorrow, the beginning of 6th period. Okay, so maybe just hold on your questions, actually see what it's all about, and then at the end of class, if you have questions about whether or not you want to use this on your quiz, you can ask that. Okay? What's your question? No. So if you use it, the highest thing gets an 85%. So all of the questions have the same directions, factor and solve. But what I've done here is broken it down into different types of factoring. The heading is kind of a clue about what to do. Your quiz will not have these headings, but it'll go in the same order. So like A times C method, perfect cubes, perfect squares. Okay? I think this is really going to help you organize your thoughts and your questions. So let's just kind of stay calm and do these problems and then address questions at the end. So you can write on this, like, you want to study it, you can write on it.
Oh, this is a A, B, C code?
Wait, so you're doing this with us?
Yeah, I'm doing it right now, so you guys are quietly working. Feel free to work ahead, and quiz yourself, you know, how much do I know? Or, you know, stay with me and do it as I do it. Yep, that's for you.
Are we allowed to use a calculator?
Mm-hmm. Yeah, I don't have any. I'm not giving any out anymore, but you can bring your own. No, there was enough missing. I don't have enough for the whole class, so it's not fair anymore. People are starting to be like, you know, giving me a hard time about not having enough. So. You gonna get one?
So if we use our phones?
No phones during the quiz.
Well, yeah.
Yeah, get a calculator. I want
Too expensive.
$20.
What?
Yeah.
Yeah, but everybody buys.
I had to ask my grandma for help, like back in high school, to get me a calculator. That was my present from my grandma. So. Reach out to somebody, y'all. I'll get you $20. I know you can do it. Okay, here we go. So this is for sheer quiet. Your clue as to how to factor comes from how many terms are in the problem. So what I see here is 1, 2, 3 terms. And that's all 3 of these first problems, whereas the bottom half of the page, the problems only have 2 terms. Okay? So that's one thing that helps you make decisions about how to factor. So when you have 3 terms, you want to use the A times C method. On your quiz tomorrow, I'm not going to put this A times C method. You have to know 3 terms. Let me try the A times C method. Okay? So I'm going to do 2 times negative 6. Actually, I'm going to come over, put it over here. I can already see that I'm going to run out of room. So write smaller than I am. Or do it on a separate paper. So numbers that multiply to negative 12 and add to positive 1, which is in the middle. Good job. 4 times negative 3. So we're going to put those numbers right in the middle. And we'll do the grouping. Kind of cover up 2 terms. Take a GCF, cover up the other 2. Take a GCF. So looking at these first 2 numbers, they both divide by 2, and they both have x. In fact, they both have x squared. So when I take a 2 out and x squared, all I have left is x squared. I'm going to write the plus sign. 4 divided by 2 leaves me with a 2 here. Had x squared and I put it out front, so there's no more right there. So maybe you want to make yourself a note. If the third term is negative, factor out a negative. So these both have 3. They're both divisible by 3. They're both negative. I'm going to put a negative 3 outside of the parentheses. And that's going to leave me with x squared. And negative 6 divided by negative 3 is a positive 2. So A times C method. I should have the same parentheses here, and that's how I know I've done it right. So we'll move forward with bringing in the GCFs together and keeping one matching set. Yes.
So before, if I remember correctly, wasn't that our final answer?
Yeah, so if it just said factor, you stop there. If it says solve, you're going to take both of these, set them equal to 0, and solve. You shouldn't leave it all. Thank you so much. Let's just set it here. Thank you.
Okay, and make sure which students have, that you know which computers they have, because you've been attempting like little vandalization.
Yes. So we'll set them equal to 0, and then you're solving by square rooting for most of these. So I end up with 2x squared equals 3, x squared equals negative 2. I have to divide on this one because of the coefficient. Same answer as yesterday.
That's just where I messed up, because like before we didn't have to solve it.
Well, when we factored before, it wasn't squared because we were factoring quadratic. So you would do this. You would do that. And actually, a lot of people would factor a quadratic like this. And then I say, you know, what are the zeros? And then they just memorize it's just the opposite numbers. And didn't know why. And the reason it is because you set both of them to 0. And you're solving the result. Well, solving this result's more complicated because it's a second degree binomial. So this whole like solving part just involves square rooting.
So to get rid of the square root, you have to square root.
Correct. The opposite of squaring is square rooting. No. The final exam was multiple choice though. Oh, you haven't taken it yet. When are you gonna take it? That was multiple choice. Yeah, the whole thing. Yeah. Okay. Yeah, because did you try watching any of the videos? The review videos? Alexis, did you try watching any of the review videos? Yeah. Alright, so we had a 4th degree polynomial and we have 1, 2, 3, 4 answers. So it's 4th degree because the exponent's here. If you have a positive and a negative, that counts for 2 roots. So when you solve by square rooting, you get a plus or minus. There's a positive and negative, that's 2, and that's 2 more. So it's 4 roots. Whenever you square root a negative, you put an I in front. What's your question? This is your final answer. that people often forget to think about the number and 1. A number in itself and 1. Should I pause here? I've got the numbers, and do you guys want to try to work ahead before I show the work? If you're in a different part of the handout and you have a question, then I'll try to come back here. So we don't need to do. We do. Okay. Yeah, I did it on the board. Oh, okay, so cool. And then this one, don't forget the plus or minus. Okay, those are the big ones. You know, seconds not they're similar, but I don't have square root here. They're both you're going to 40, so that's a 5. It's the same. You didn't write. I didn't write a square because this is. Yeah, but you took 3. Yeah, but you took an X out here. So that's just X. Because it's not. Wait. Is that right? Yeah. That is? Yeah. Oh my gosh. Good job. Yeah.
I factored 5x to the 4th plus 25x to the 2nd. How would you factor negative x to the 2nd?
We're just gonna take a -1 out of there. They're both negative, so anytime you can't take anything, you're either gonna put a +1 here or a -1 here. So I'm just gonna turn them both positive. Yes, Savannah.
You always line up the x with whatever the x in the problem was, so you would make it x to the power 2. No problem with that. But if it was like x.
X to the first.
Yeah, in the problem. Yeah, I'm just making sure.
Yep. Yeah, those are the X one is matched. Yeah. Well, that's what's new here.
So how does that? She was like, 5x squared parentheses. How does that x become an x squared? Like why is it called x squared?
Yeah, because I told you.
This right here.
Yeah, no.
This right here.
Yeah.
Well, it's 4. It's 4. And they both have 2. I put 2 out front. So if I had 4 and I took 2 away, I have 2 left over.
But why did it become an x?
Because I took 5 out and put it in front. Here's your answers for number 2. Nice job. Any specific questions about these numbers or these processes in this one? You finished this one, Tom? You finished this one? All right, anybody want to take a picture before I move on? No, so I'm considering a bonus question that involves graphing. And so the bonus question would be like, choose one polynomial to graph the zeros. Like sketch a graph of one of these. And you have these answers. So you may want to make them a decimal for that bonus question. You can make that connection. Then you solve that. So 0 divided by 3 and 0 square rooted. Cube rooted. Yeah. All right, so this example has the greatest common factor in it. On your quiz, I'm not going to tell you, is there a greatest common factor? So all three of these numbers divide by 3, and they all have at least x to the third in them. So I'm going to start by dividing them all by 3 and taking x to the third out. No, we're going to do the whole thing the same, but there's a little something different in the beginning. If you can divide all three by the same number, you always do that because it makes your numbers smaller and easier to work with. Yeah. And now we're back to number 1 and 2. We do that same method now. Should I wait? You're just working at your own pace. Put your 8 and 5 in there. What about the 3? We're going to ignore it for a while. That guy's just sitting out there getting ignored. A lot like the equal 0. So Alexis, this is actually a little bit of a review for the exam. You know, be on there a little bit. I had Kaylin, I had 2x minus 5. Yeah, I took a 5 out of it. What'd you put in the middle, 8 and 5? Yeah. Did you put the 8 first or the 5 first? Yeah, so I took a 5 out of these two. Did you? Okay. Maybe I just didn't see it on the paper right. I don't. So, someone to divide. You could check with somebody else. Oh, it's probably pretty close. All right, so we got this is actually 5 answers. Since this was x to the third equals 0, it counts for 3 roots. That's called a multiplicity. that x to the third equaling 0 is 3 roots. This is 1, which makes 4, and then 5. So we found 5 roots for this 5th degree polynomial. Well, we have 4 problems left, and these are shorter, so I think we'll finish. Because the exponent on the original problem is 5, I want 5 answers. And so this one counts for 3 because it came from x to the third. All right. Well, Matt, do you remember the pattern for cube rooting? Mm-hmm.
Oh yeah, that's the stuff that we did.
Let's hear it. Let's hear if you remember it.
That's you have your binomial, and that is x, right?
Yeah.
Oh, you wanted that.
No. You understood. Just x in there.
One second, let me get my chart out. 7.
Sure.
It's 7. Now it's positive 7.
Are you missing the other half of the parentheses? I thought you did it for a reason, so I was confused. Something that bad.
Can we write the contract from the last time?
Well, you're gonna write it right here, yeah. If you're gonna write it on your handout, use it, yeah. Use your handout. You could complete the square, if you remember that, but it would be completing the square with fractions.
We never did, we did this, and I thought that was easy, but then I could never solve it. Yeah, I thought that was the answer.
Do you always use the quadratic function for that last binomial?
On all perfect cubes. Okay, yeah. So it's x to the third, and this is in your list of cubes. You can put a list of cubes on the back of your handout too. So I switched from trinomials to binomials, from 3 terms to 2 terms. For 2 terms, you're looking for either cube roots or square roots. Does that help? All right. Yeah, I gave you more problems to practice. But I'm not done with this, so no, not right now. I need to work on this for 14 more minutes. I wrote it yesterday. Can you look yesterday, your notes?
X equals negatively plus or minus negative.
I mean, I did. You didn't write it yesterday? You don't think? I mean, I can only write it so many times. You already wrote it yesterday, guys. So get it out. Just get it, yeah, I gotta empower you a little bit more to search out things for yourself.
Yeah, I got it out.
4 times 50 is 200 minus 4 is 96.
Wait,
Mm-hmm.
is it x equals negative b plus or minus square root of negative b times a, or minus negative 4 over
You messed that up somewhere. Page was 49, take away 196. Page, will you do 49 minus 196 for me? 49 minus 196.
Oh, 147, maybe.
Thank you. And does that guy simplify it all? 49? Sure, look at those numbers.
It should be 7 times square root 3. Why are we like dividing and then multiplying? Why do you have 49 times 3?
I'm simplifying a square root. I'm simplifying a square root, so make this note to yourself. Like YouTube, how to simplify square roots. Or simplest radical form, which is a topic in geometry, algebra 1, and first semester. Other questions on number 4. We got -7 and 7 plus or minus 7i square root 3 all over 2. It's good work. Yeah, very good. Do you want to take a? Does anybody want to take a picture of that?
Wait 1 second.
I didn't write it. Jackson, what'd you get for 5? And keep it going. It's a whole math workout. Yes.
That's 49.
Sorry, it's times 3. So I searched 147 for perfect square factors, and they're divisible by 49 and 3. Oh man, so it's really 7 problems. Do you understand that, Victoria?
So,
It's just auto numbering.
oh, so you moved this, like 49. Wait. Times 3, you just moved the 7 to the outside with the I. Or, yeah, because
Square root of the 49, yeah.
oh,
All right, I'm going to skip the other cube. You guys should still do it. I'm going to do the last 2 first. Not after you take a DCF out. Yep, they both divide by 8. And then you're going to factor that.
What, is it a difference of cubes?
Oh, cross that out. I did 2 sums.
So we're counting the word difference.
I'm putting sums.
so is that quadratic formula?
Is it not
4m squared plus minus 4. There you go.
Why did you get the 2i because you divided it by 4?
The cube root of 8 is 2.
Oh, that, or Matthew, what if you put the thing where you have to flip it?
The screen. That's one question.
Is that the one?
Wait, how many questions are there?
Remember when you
Is that
had to
just
flip
one
it?
or
Oh, I never.
That is true.
You just take out negative 1.
You can solve like so many square rooting problems in geometry.
No.
Like when you do the Pythagorean theorem.
Julie, not kidding.
Nobody asked you that. Okay, look. Just solve your square roots. I just thought like it was a big part of geometry curriculum. So I'm gonna keep going with this. I'm gonna keep going.
Do we do quadratic formula for number 5? Not that 5.
What's the matter with this one? Do what? No. What's your question, sir?
Do we do quadratic formula for the polynomial?
Yeah, you always have to do the quadratic formula for this one.
But is there ever a time
Not for a cube. If you do this binomial, trinomial, this one always has to be quad formula. Jade? I'm going to square the first. So 2 squared is 4. M squared. So you see how this x got squared right here? This 2m gets squared right here. Look at your cubes that you did.
No, you have to do quadratic.
You do quadratic formula.
Is it really half credit on this?
I always give partial credit.
That's why I don't get most of the steps done.
Like right here.
Yeah. Well, I feel like confident in that stuff, but the like quadratic formula, I'm not really confident about. Like I can do the.
So it is posted in Khan Academy. There are some quadratic formula practice problems.
Like I can do the squared or not the squared, the sum of cubes.
Uh-huh.
I can set that up, but then after I set it up, I don't know how to do it.
Yeah. You don't know how to plug into it? I'll give you credit even for plugging into it correctly. Okay. Yeah, do everything you can. Yeah. It's just simplifying, squaring and subtracting. Hey, who's got a question on the second number 5? Yeah, there's 2 number 5s.
Why did you put that 25 on the outside?
It was a GCF. Like they both divide by 25. Yeah. Yeah.
And then, did you just distribute that 4x so it goes x squared plus 2 and an x squared?
I looked for what multiplied to -4 and added to 0. Or you can think of it as square rooting. So 25 doesn't equal 0. I put a line through it. It's a contradiction. It's not an answer. Good question. So you can take a picture of those if you didn't get to them. You don't have to do it for m squared minus 9. It's just as right if you add 9 to both sides and you get m is plus or minus 3. That's just as correct as factoring. Are you going to be collecting this for points? No, this is for you to keep and use on your quiz. Jade? Not quiz. Right here?
I was
I put the I here.
No, I did not.
Yeah, I did. You're right.
What is that?
You guys just 2 minutes. Come back to your seats. Kaylee and Eva, come back to your seats. Just wait till the bell rings. Yeah.
For the quadratic polynomial on this one, we only use the numbers in this one.
Yeah.
Only that.
All right, so in the beginning of class tomorrow, I'll put up the answers from your textbook. I'll put up the answer to that one, and then you'll have a little mini quiz.